Today I will be explaining you what are sensors. Overview. What are sensors? Detectable phenomena. Physical principle. How do sensors work? Need for sensors. Choosing a sensor. Sensor description. Temperature sensor. Accelerometer. Light sensor. Magnetic field sensor. Ultrasonic sensor. Photogate. CO2 gas sensor. What are sensors? American National Standard Institute ANSI definition. A device which provides a usable output in response to specific measure. Second point, a sensor acquire a physical parameter and convert it into a signal suitable for process. A transducer, microphone, loudspeaker, biological sense, example touch, slide, etc. Detectability phenomena, stimuli and quantity. Stimuli consist of acoustic, biological and chemical, electrical, magnetic, optical, and thermal. On the basis of stimuli, it is defined for qualities also. On acoustic, wave amplitude, phase, polarization, spectrum, wave velocity, biological and chemical, fluid concentration that is gas or liquid, electrical charge, voltage, current, electric field, amplitude, phase, polarization, conductivity, permeability. On the basis of magnetic field, amplitude, phase, polarization, flux, permeability. Optical, refractive index, reflectivity, absorption. On thermal, temperature, flux, specific heat, thermal conductivity. What are the physical principles? The physical principles are first Ampere's law. A current carrying conductor in a magnetic field experience a fold. That is, or an example is a galvanometer. Curry-Wells law. There is a transition temperature at which ferromagnetic material exhibit paramagnetic behavior. The third law is Faraday laws of induction. A coil resists a change in magnetic field by generating an opposing voltage/current. Example is transformer. Photoconducting effect. When light strikes certain semiconductor material, the resistance of the material decreases. That is photoresistor. What are the need for sensors? Sensors are omnipresent. They embedded in our body, automobile, airplane, cellular, telephones, radios, chemical plants, industrial plants, and countless other applications. Without the use of sensors, there would be no automation. Imagine having to manually fill Poland spring bottles. Choosing a sensor. We choose a sensor based on three factors that are environmental factor, economical factor, and sensor characteristics. On environmental factor, it depends on temperature range, humidity effect, corrosion, size, overrange protection, susceptibility or to EM interference, ruggedness, power consumption, self-test capability. On economical factor, cost, availability, lifetime. On sensor characteristics, sensitivity, range, stability, repeatability, linearity, error, response time, frequency responses. The first sensor is temperature sensor. Temperature sensors appears in building, chemical process plants, engine, appliances, computer, and many other devices that require temperature monitoring. The second point is many physical phenomena depends on temperature, so we can often measure temperature indirectly by measuring pressure, volume, electrical resistance, and strain. Temperature sensor. It is bimetallic strip. The formula is L equal to L naught into 1 plus beta into T minus T naught. Here we can see a metal, two metal placed very close to each other. Application. Thermostat makes or breaks electric connection with deflection. On the basis of resistance temperature device, the formula is R equal to R naught 1 plus alpha into T minus T naught. And another formula is R equal to R naught e to raise gamma into 1 upon T minus 1 upon T naught. Thank you.
Hello friends, I'm Mr. Akash Bodke from Instrumentation and Control Engineering, roll number 7. Today I would like to discuss the sensor. Now I will move forward with accelerometer. Accelerometer are used to measure along one axis and is insensitive to orthogonal directions. Application of accelerometer are vibration blast impacts, shock waves, airbags, washing machine, heart monitors, and car alarms. Mathematical description is beyond the scope of this presentation. Light sensor. Light sensors are used in cameras, infrared detectors, and ambient lighting applications. Sensor is composed of photoconductors such as photoresistor, photodiode, and phototransistor. Magnetic field sensor. Magnetic field sensors are used for power steering mode, security purposes, and current measurements on transmission lines. Hall voltage is proportional to the magnetic field. As we can see here, VH is equal to IP upon NQT. Ultrasonic sensor. Ultrasonic sensor are used for position measurements. Sound waves emitted in the range of 2 to 13 megahertz. Here we can see the sonar system, sound navigation and ranging, and also radar, radio detection and ranging. Photogate. Photogates are used in counting applications. For example, finding period of periodic motion. Infrared transmitters and receivers at opposite end of the sensor are brought about by photogates, and time at which light is broken is also recorded by the photogate. CO2 gas sensor. CO2 gas sensor measures gaseous CO2 level in the environment, and this sensor also measures CO2 levels in the range of 0 to 5000 ppm. This sensor monitors how much infrared radiation is absorbed by the CO2 molecules. Thank you.